Hey, yesterday we defined the 6 trigonometric functions, and I want to say a little bit more about those today, and then we're going to talk about degrees, minutes, and seconds, and put those things together and work some application problems. But so I want to finish up on the 6 trig functions yesterday, and just since we defined them, I want to just make some observations about them and look at what we can do with them so far. Now remember that we've got sine, cosine, and tangent, and then the reciprocals. So sine is alpha. Sine of alpha here is opposite over hypotenuse. Cosine of alpha is adjacent over hypotenuse. And tangent of alpha is opposite over adjacent. And then you have their cotangent, reciprocal of tangent, cosine, reciprocal of secant, or secant, reciprocal of cosine, and cosecant, the reciprocal of sine. So that's just what we did yesterday. Okay? Okay? Now let's look and see what kind of things we can do with that so far. In other words, what we might be asked to do. First of all, and we looked at this a little bit yesterday, we have sine alpha equals 2/5. And what we want to do is we want to find the other 5 trig functions. So, first thing you need to be able to do is, now, is there anything we know right away about this? We know sine equals 2/5. Do we know anything about any of the other trig functions right away, immediately? That's right, cosecant. We know right away that cosecant is equal to 5/2. So that's one of the things. It looks like you're starting to get that really burned in to your brains, that cosecant is a reciprocal of sine. So if you're given sine, you know cosecant right away. Now, what we don't know are the other trig functions. So what we need to do is figure out what the adjacent side to alpha is. So how do we do that? Yes, sir. Well, the Pythagorean theorem. I know what you're saying. Look, we've got this relationship. Let's call this side x. We know this. The Pythagorean theorem tells us that x squared plus 2 squared is equal to 5 squared. We know that from Pythagorean theorem. That is the theorem. Now, what I can do to figure out what x is, I'll just subtract the 2 squared from both sides. And then I have 5 squared minus 2 squared. That's 25 minus 4, right? So we have x squared equals 21. So that must mean that x is the square root of 21. If x squared equals 21, we know that x equals 21. Any questions about that? Well, now we're ready to go. We can just apply the formulas because, look, we know that now cosine of alpha is equal to the adjacent over the hypotenuse, right? Now, if that's cosine, what else do we know immediately? That's right. Secant, which is 5 over the square root of 21. And if you don't like having the radical on the bottom, you can multiply the top and the bottom by the square root of 21, and you get rid of it. Okay. So now we've got sine, cosine, we've got cosecant, secant. What's left? Okay. We need to get tangent. Tangent of alpha, what's that going to be? Opposite over what? Adjacent?
Yes, sir.
Okay, so that's 2 over the square root of 21. And now, if that's the case, what is cotangent?
Square root of 21 over 2.
Square root of 21 over 2. And that's it. And of course, we can rationalize the denominator here and get 2 square roots of 21 over 21. Okay. Any questions about that?
Yes. How do you draw that little sign?
What sign?
Alpha?
Oh, it's just like a alpha. It's just like a 2. Okay. Now let's I want to formally write down this idea about the reciprocals. I mean, we've noticed it, but I want to go ahead and formally write it down for you because I want us to take stock in what we should know of it to this point. Of course, we've got the 6 trig functions defined there. And what we want to note is this. And later on, we're going to get into this thing where we're going to learn a lot of what's called identities. We're going to learn how to write trig functions in terms of other trig functions, and we're going to learn quite a few of them. And this is one of the first ones, or these are one of the first ones, the reciprocal identities. And we note that sine alpha is 1 over cosecant alpha. And of course, that implies that cosecant alpha is 1 over sine alpha. Right? So we know that those are the same things. Now also we know that cosine alpha is equal to 1 over secant alpha. Likewise, that implies that secant alpha is equal to 1 over cosine alpha. All right. Any questions? Now finally, we have tangent alpha is equal to 1 over cotangent alpha, which implies that cotangent alpha is 1 over tangent alpha. Okay. Any questions about that? So look, here's what we've got. We've got the 6 trig functions defined. Immediately from that definition, we note this, that these reciprocal identities.
Okay, I see why it's 1.
Okay? Any questions about that? This is what follows immediately from these definitions, and that's what we want to take note of. Trig is like that. In math in general, you're given certain definitions, certain foundational knowledge, and then you say, okay, what's implied from that? Well, what's implied from these definitions is the reciprocal. So when we're given sine and cosecant, when those are defined this way, we know we automatically see, well, okay, those are reciprocals. And we can substitute. Anytime we see 1 over sine, we can replace that with cosecant. Anytime we see 1 over cosecant, we can replace it with sine. Okay. Now that's important. And you might not think it is at this point, but later on we're going to start using the calculator to figure out some trigonometric values for some angles. And if you're given cosecant of, let's say, 15 degrees, well, there's no cosecant button on your calculator. You have to recognize that cosecant is 1 over sine. Okay, so that's the way we would handle that with our calculator. So there's certain things you just need to know, and that's one of them. Any questions about that? Okay, let's look at something else. Another observation I want to make is related to the Pythagorean theorem, and it's called the Pythagorean identity. This is a very important identity, and I want to introduce it now because it's something you're going to see over and over again. But the Pythagorean identity goes like this. Let's look at this. Let's look at sine alpha. We know that it's equal to A over C from the previous slides, the previous triangles we looked at. Let's suppose, and I realize we talked about this a little bit yesterday, but like I say, I want to formally just state it here. Let's suppose we look at sine alpha plus cosine alpha, and we want to see what that equals. Well, sine alpha is A over C, so sine alpha squared is A squared over C squared, plus cosine is B over C squared. Now look at what that would be. That's going to give us A squared plus B squared all over C squared. Does everybody see that? Now we know from the Pythagorean theorem that A squared plus B squared does equal C squared. So that gives us C squared over C squared, which equals 1. Now what this illustrates is it's one of the Pythagorean identities. And the Pythagorean identity just says this: sine squared alpha, we're using alpha, we could use anything, x, beta, whatever, plus cosine squared alpha equals 1. This is one of our Pythagorean identities, and we're going to actually learn 3 of them. But this is the first one, and this is the only one I want to look at right now. Later on when we talk about identities, we'll build on this. Okay. Any questions about that?
Still can't draw the little alpha sign.
Okay. So a couple of observations. Look, we've learned the reciprocal identities and 1 Pythagorean identity along with the definition of the 6 trig functions. Any questions so far? Okay. Now, this one's pretty interesting also. Notice that we have a triangle here and we have 3 angles, of course. We have the right angle and we have 2 other angles, alpha and beta. Now, do you know anything about the measures of alpha and beta? If I add up alpha and beta, what is that going to equal?
It's going to equal that.
What is the sum of the measures of angles of a triangle?
Oh, 180.
180. Here's 90 degrees. What are these?
Oh, so it's going to be a
90 together.
90. That's right. The alpha plus beta, the sum of that's going to be 90 degrees. That means that alpha and beta are complementary. Now, let's note this. Let's just find the sine of alpha. What is the sine of alpha? It's A over C, right? Okay, so we have A over C. Now, let's find the cosine of beta. What is the cosine of beta?
A over C.
Yeah, look, because here's beta, adjacent over hypotenuse, so it's A over C. Now you notice that the sine of alpha is equal to A over C, and so is the cosine of beta. Alpha and beta are complementary, and look at their cofunctions. Sine alpha is A over C, and its cofunction is A over C. Yes, sir, Josh?
What if you're trying to find like the sine of the right angle? You can do that, right?
Yes.
Okay, so it'd be like 1, and then...
That's right.
And then what about for the cosine? I mean, you would have 2 that are adjacent, so...
Well, I'll show you. Remind me in a little bit, and I'll talk about that with you. Okay. Now, look at this. Let's suppose we have, what? Secant. What is the secant of alpha?
Secant C over...
Okay. C over... Okay. Now, secant, remember, is going to be opposite over adjacent, right?
Yes.
C over B.
Sorry.
Okay. Now, what about the cosecant of beta? The cosecant, remember, is going to be the opposite over the hypotenuse over the opposite, so that's C over B. And once again, notice the cofunctions. The cofunctions, secant of alpha and cosecant of the complement, they're both the same. Now look at this. What about tangent?
A over B.
Tangent is going to be opposite over adjacent, which is A over B. And what about the cotangent?
What?
Cotangent of beta.
A over B.
Right. Here's opposite over adjacent. Okay. Any questions about that? So this is something else we note here. We note that complementary angles, cofunctions. If you take the cofunctions like sine, cosine, secant, cosecant, tangent, cotangent. If 2 angles, alpha and beta, are complementary, then taking the sine of one and the cofunction of the, like for example, the sine of one angle and the cosine of the other, you're going to get the same value. Okay. So, to illustrate, if I have the sine of 60 degrees, by the way, what is the sine of 30 degrees equal? Do y'all remember from yesterday?
Oh, A equals...
It's 1/2, right? what is the cosine of 60 degrees? 1/2. That's right. So in other words, if you are told, if you're told that, for example, the sine of, so if you're told the sine of alpha equals k, then the cosine of beta is equal to k also if alpha plus beta equals 90. If that happens, then you know that's true. Any questions about that? Okay, so that's another observation we want to